Namaste, Mr. Bossert here, and we're starting Chapter 8 today, talking about Chapter 8 dealing with two variable equations and the relationship between the two variables. And most of the time, we'll use x and y because of the x-axis and y-axis. So we can see that relationship and graph it and examine how the two variables work with each other. So just like a relationship between two people, a relation in mathematics is a set of ordered pairs, right? X's and Y's, typically. They don't have to be X's and Y's, but typically that's what we do so that we can then graph them on the x-axis and y-axis. And a relation is any set of ordered pairs. And we'll get to that word function here in a second, but a function is a special kind of relation. All right. So, an set of ordered pairs. Okay, well, so again, relation is a set of ordered pairs. And I asked this, I think last year or the year before, right? We talked about your age and what your height is in inches. And so I polled one class of students, and this is the data that we got. And so it's a set of ordered pairs. The first number is the age of the student. The second number is how tall they are. So this first student would be 12 years old and 4'9", it looks like, right? 57 inches. 60 inches would be 5 feet tall. 13 years old. So we've got this. And then I went and zoom in on this. How do we zoom? Well, if we zoom in up on the top right here, I have, if we plotted, right, all of these points, 12, 57, 60, 62, whatever, and 13, right, they would not kind of all, you see this this plot, it's a big kind of jumbled mess. And this one doesn't form a line. A lot of the ones that we will talk about in this chapter will form lines or other predictable shapes. This group or set of ordered pairs does not. All right. Okay, so, all right, very good. So, a function is a kind of relation in which the input and output have a one-to-one relationship. Okay, so if we have this equation here, sorry, in black, y equals 2x plus 5, all right, that's my relation. I've got x and y, and they have a relationship between the two of them. The relationship in this case is, if I take x and I multiply by 2 and add 5, I'll get the y value. And you've done this in the past here, right? So we've put numbers in for x, so they'd be the input values, all the numbers I put in for x, and I get numbers out for y, or output values. So when I have an equation that's y equals something times x plus something, or whatever, something that looks like this, in other words, y is solved, y is by itself, we can say that this is in function form, because I'm going to be able to put one number in for x, and I will get one number out for y. So they'll have that one-to-one relationship. The vocabulary word domain. The domain is all of the numbers that can be inputted into the equation for x, if that's my input variable, which most of the time it will be. So the set of all the input values is the domain. And the set of all the output values is called the range. And I think you've heard those two words before. Essentially, all the numbers I can put in, right, are the domain, the inputs. All the numbers I get out as a result are the outputs, or the y values. So from here, I could put 1 in for x, and then simplify the right side of the equation and get 7. So when x is 1, the relationship that is that y would be 7. So 1, 7 would be an ordered pair that is the solution. 1, 5 is not an ordered pair because when x is 1, y can't be 5 because that would say 5 equals 7, because we know when x is 1, this right side is going to turn into 7. So 1, 5 would give you, if y is 5 and then x is 1, you get 5 equals 7, which is not true. So these are numbers, x's and y's, that make it true. If I put 2 in for x, I would get 9 out for y. If I put 4 in for x, I would get 13 out for y, because 2 times 4 is 8 plus 5 is 13. Alright, now normally the domain, if we look at letter A, the domain, sometimes we'll be asking you what is the domain for the function. And typically the domain is anything I would like. I can choose any numbers I want for x. And if for letter A, I can pick any number I want. So the domain is any real number. Right? The domain, let's see here. The domain would be x can be an element of the set of real numbers. Or you can say x is any real number. Whatever that says. So that I can pick out any number for x, and the range actually would be any real number as well. Because there are all can we stop that? Okay. All possible values of y would exist here too. The domain for letter B, we should have an idea about this. Right? It's more normally you want to say it could be anything, but it can't be anything here. Why? That's right, because negative values give you something that gives you a not real answer. So the domain here for this one would be x has got to be greater than or equal to 0. And again, the outputs for y, the range there would be, well, y is never going to be a negative as well. Y will be 0 or greater. So the range would be y is greater than or equal to 0 there. For C, we should know that we can't divide by 0, but x could be anything else. So in this particular one, x would be any number but 0. And in letter D, I would only have an issue or something that wouldn't work if x was 3, because that would make a 0 in the denominator. So in this case, you'd say x can't equal 3, or x could equal any real number except for 3, or something like that, something along those lines. Alright, so again, as a review here, a function has a one-to-one relationship between inputs and outputs, and it's a relation where every input has exactly one output. That's a function. Any relation that has every input has exactly one output. So in the last couple slides ago, when I put numbers in for x, one number in for x, I get one number out for y. That is a function. And the inputs are the x values, outputs are the y values. If that's the case, the x values are the inputs, and the y values are the outputs, we could say that y is a function of x if it has that one-to-one relationship. Now we're going to talk a little bit more about this, but slope talks about the consistent change in the relationship, and how if the relationship is linear, then it has a constant change, and the way that the y changes compared to how x changes, that ratio is called the slope. We refer to it as either rise over run, and we're going to describe it a couple different ways. This triangle y over triangle x, that triangle is it means it's a Greek letter delta, and delta means the change in. So the change in y divided by the change in x. So how the y values change compared to how the x values change, that's the slope. Algebraically, or formulaically, I guess we could say, right? How do you find change? You subtract. So you take y2 minus y1. Now that indicates a second y minus the first y, so like first and second points. So if you subtract two y values and divide that by subtract the x values that go along with that, that gives you the slope if it is a line. Alright, we're going to talk a little bit more about slope and finding slope in next section. So thank you for listening.